Number 8, air is being blown into a spherical balloon at a rate of 80 cubic centimeters per second. At what rate is the surface area of the balloon increasing when the radius is 15 centimeters? And we're given formulas for volume and surface area of a sphere. It's not really clear why we have two formulas there. Seems like we just need the surface area formula. And this is a related rate, and what we're looking for is what the ADT is equal to. Okay, this 80 is the rate at which the air is being blown in. So that means that the VDT, the change in volume, is 80 cubic centimeters per second. And at some point the radius is going to be 15. But don't do that too early. Okay, well, it's not really clear what's going to happen here, but we need the ADT, so let's take a derivative of the A formula. The ADT equals derivative of 4 pi r squared is 8 pi r, the r dt. Don't forget chain rule. Every time we do related rates, you stick on d dt, whatever the variable is. So this is a dr dt. Okay, great. So we're trying to find the ADT, and I guess I can start plugging in here. So this is 8 times pi times the radius when we pause this video is 15 times the r dt. And there's nothing in the problem that says what the r dt is. So we need to find the r dt. Well, the only other thing that we know is the VDT. So maybe this would be a good time to take a derivative of the volume formula and see what happens. Again, we're kind of running on faith here. The VDT equals, so take a derivative over here. Don't need to use the product rule. 4/3 pi is just a constant sitting in the front. So the 3 from the r cubed comes down and just gives you a 4 times pi times r squared times, again, the chain rule, the r dt. Okay, so what can we do if we plug in stuff in this formula here? So dv dt we know is 80. That's equal to 4 times pi times the radius, again, it's fixed, is 15. That gets squared, times dr dt. Well, that's very good because it means we can solve this equation for dr dt and then plug it in for the turquoise highlighted part. So this guy comes down here and tells me that dr dt is equal to, all right, we'll just write it, 80 divided by 4 times pi times 15 squared. And so I can put that for the dr dt in here. Okay, you're welcome to just type this into the calculator carefully. I guess I'll go ahead and simplify a little bit first. The pi's can cancel. I guess 4 and 80 make a 20. This 15 will cancel one of those 15s. So what do we have left? Let's see, there's an 8 in the front. There's a 20 in the parentheses. And I think there's a solitary 15 in the parentheses. Make sure that's okay. I think that looks good. And then 20 and 15 you can reduce to 8 times 4/3. So don't even need the calculator. 32/3, or about 10.67. Doesn't say include units, but just in case it did, let's make sure we can. So this was the ADT that we were finding, which means A units over T units. The area, surface area of this balloon is in square centimeters per, and then time was in seconds. So this is 10.67 square centimeters per second. That's the rate at which the surface area is increasing at this particular moment when the radius is 15 centimeters.